Okay, so presenting for us today, we have Evan Liebens. So he is currently a prep cook at Sarah's Table, Chester Creek here in Duluth. In the summer, he'll be working at Northern Harvest Farms in Renville. After graduation, he will be going into food systems and working there to help strengthen community food webs and support food security and sovereignty. Today, he'll be presenting to us on the variables and implications of nutrient density in food.
All right. Well, thank you very much for the introduction. Appreciate it. Yeah, we're gonna talk about food and nutrients. It'll be a lot of fun, so let's get into it. I just want to set a quick disclaimer because I'll be talking about nutrients and health, and people might not have the best relationship with food. And overall, no matter what I say in this presentation, please just remember to give your body what it needs. You know how your body works, so eat the foods that are right for you. Maybe I'll just give you some insight that you haven't considered before when it comes to eating food. There's no magic health diets that works for everybody. And plus, I eat processed foods and unhealthy foods, and there's no healthy foods either. First, we're going to start with actually defining nutrient density, and then we'll also go into what a nutrient is, and I'll discuss the variations in nutrient density between foods. And then we're going to talk about how that variation even happens in the first place, and then we'll discuss this decrease in nutrient density that has happened over time in all foods. And then we're going to talk about what that means, what that decrease means for humans and the planet. So in terms of what nutrient density actually is, it is the number of nutrients per calorie. So it's the amount of nutrients that is in one that comes alongside or compared to how much energy you're actually getting. This is usually defined and can vary on a macronutrient or obvious scale. I'm going to go more into what a macronutrient is. But for example, something like a Capri Sun is going to have way more energy or sugars than it does nutrients, like that would come from juice, compared to something like apple juice, which would have more nutrients per the amount of sugar or energy that you're actually getting. And then, I mean, we're going to get into this, but it can also vary on a micronutrient level between foods. And this is more subtle and nuanced. So then we're going to define what a nutrient is. If I'm talking about nutrients per calorie, then further, what is a nutrient? So right now it's conventionally based on government regulation. It's kind of used as a reference for nutrient uptake. So think of things like the food pyramid that's not really used anymore. My plate, I remember seeing these in elementary school, like on the walls and everything. And even in our daily lives with things like the daily values, it gives you information on what nutrition you're actually receiving. So these things mostly do with macronutrients. So when you're looking at the label, think of things like carbohydrates, proteins, fats, cholesterol. These are primarily things that are really essential for life. If you don't get these, you will cause detrimental effects very quickly and in very great amounts. And this also includes vitamins and minerals, essential for a lot of the body's functions and survival. So micronutrients, kind of a gray area because they're not strongly considered in the conventional definition of what a nutrient is, and they're not considered by these regulations either, because they're considered to be non-essential. They're not as like foundational or core. We'll get into those more. So they're mostly phytochemicals. Phyto means plant, so plant chemicals or pre-vitamin compounds. they're really important though. They have large implications on human health, which we'll get into, and they vary greatly between foods. So you would think that we would keep better track of them. So in terms of what micronutrients are, they again, they're either plant chemicals or vitamin pre-vitamin compounds. So you don't have to know this whole list. This is a biology presentation. It's not a chemistry presentation, and so this isn't going to be memorized at all. And this is part of the reason that it's kind of hard to keep track of phytochemicals because they're so diverse. But keep in mind antioxidants, polyphenols can have certain growth effects on microorganisms. Carotenoids are like the what gives vegetables their pigments, and flavonoids have different antioxidant activity, but those are all grouped under phytochemicals. So plants can produce thousands of these things, and they mainly contribute towards defense from either herbivores. They can also contribute to antioxidant activity, both in the plant and in humans that consume them. And they also contribute to flavor. They make your food taste better, and they can make your food last longer, and they can work with each other to actually form further compounds along the way in the digestion process. They have anti-tumor properties as well, and doubling down on the antioxidant activity. For example, there's birds that after long flights will consume berries that are high in antioxidant activity in order to help their muscle healing. In addition, they support microbiota in plants and animals. They can like think about the gut microbiome or even within the soil that we'll get into. And this is really helpful to know because certain polyphenols from things like green tea, honey, peppers, black currants have exhibited inhibitory effect against H. pylori, which is a common bacteria in food poisoning. And I should have known this because I haven't eaten at an Outback Steakhouse since I was 9 years old when I got food poisoning, and I was out of school for a week. So I guess I should have eaten more honey or drank more tea or something like that. So these are important, and I want to go more in depth into their specific benefits. So most non-communicable disease suppression, chronic disease suppression, and cancer suppressing effects in vegetables and fruits are attributed to these phytochemicals. So when you have a high amount of micronutrients in your diet, it can reduce your risk to chronic disease and non-communicable disease. It can reduce inflammation, your cholesterol, and you can lose body weight when you're getting, again, going back to the nutrient density idea, when you're getting more nutrients per calorie that you're consuming. And it can improve your metabolism, and again, it blocks tumors, and it can also contribute towards your quality of life. When you consume micronutriently dense food, it makes, for example, the effect of being hangry lower. You are more satisfied with that feeling of hunger, and it results in more true hunger, which happens in your throat, more of like that like head hungry. This is why food is so important to me, because if I don't eat, if I'm grumpy, tell me to eat a sandwich, essentially. And so some of them are directly good for your system, and then some of them directly support microorganisms. But you know, what's really the difference between those two? But that some of the microorganisms can really utilize these compounds. So these are really important. Again, we would think that we would keep better track of them, especially because they can vary significantly between the different foods that we eat. So we're going to talk about this variation. In the first place, how do we know it's there? How do we measure it? lasers. It's a cited source. So again, this isn't a chemistry presentation, but think spectrophotometry and chromatography, spectroscopy, stuff like that. And so just in general, foods can vary based on their seasonality, ripeness, where they're grown, what type of soil they're grown in. And then in addition, how they're processed after they're collected. So as soon as you harvest something, it's the time is ticking, basically. Once you pick a fruit or cut off a piece of broccoli, the plant is still alive. That part of the plant is still alive. So it's going to be either increasing that sugar content or respirating, essentially, in the vegetable's case. So for example, it's the case in a lot of tomatoes. I call it the booger method because you pick the tomato when it's green, and then it's easier to transport because there's less volatile compounds, but then the micronutrients in that tomato is less because you've picked it early and it hasn't finished its ripening process. And later, it's usually treated with ethylene. And storage has different effects too. And for example, spinach, vitamin C in spinach decreases about 40% after a week, even if it's refrigerated. And frozen food, so if you get like frozen berries, that content is pretty similar to how it would be if you were to eat it right off the plant. Freezing things really preserves a lot of the nutrients. But this variance really doesn't happen with macronutrients. There's not a huge depending on the soil type and ripeness and things like that, except for extreme cases. The macronutrients usually stay the same between varieties, but it's the micronutrients that are where we see most of the variance, and minerals too. So this is not only between different crops, but between this, it can be between the same cultivar within the same type of food. Despite the fact that all of the labels say that this carrot, for example, has this amount of nutrients in it, always. It's taken from a national average, but there is variance there. So going back to the point of comparing foods. So obviously, an apple is more micronutriently dense than something like a Twinkie. And I can't tell you which is more dense than the other, but you can compare, let's say, one crop to the other. But I'm saying further that you can compare literally the same apple to another apple in terms of its micronutrient content. And that is not Dr. Paul Bates, that is Woody Harrelson, by the way. But why does this variance occur? Because of farming. So now we're going to talk about farming for a second. So again, the same cultivars. This is one I feel that I need to read directly. The same cultivars bred for and grown under different farming systems can exhibit substantial variability in micronutrients and phytochemical density. So this is under the paradigm that soil serves as the foundation for healthy plant growth and further its micronutrient content. So here we go, boom. We're going to talk about organic and conventional farming. It's a really contended subject, but for good reasons. I think that, so this is kind of similar to the nutrients, where these terms are very it's based on the word itself. It's a legal distinction at this point. Organic didn't originally start as this, but it's turned into you have to meet a certain amount of requirements in order to be organic. So this is good because I guess it promotes things like using more natural systems, and it doesn't allow the use of fertilizers and such. But this causes some food producers to meet the very minimum that it takes to be organic. And just because a food producer is organic doesn't mean that it's going to be healthy and it's way better, and it can still be destructive. Organic and conventional have the ability to cause the same amount of damage to the soil, and even though conventional uses more fertilizers and such. So essentially, I'm going to focus more on farming systems that will actually promote soil health, not just the ones that meet the minimum legal requirements, but the ones that promote healthy soil health. Healthy soil are usually attributed to organic practices. We'll get into it. So we're going to get into the importance of soil. So again, soil being the foundation for healthy plants. So crop mineral nutrition is based around plant-soil interactions. This can be in terms of organic matter. Organic matter obviously provides nutrients, but it also encourages microbial growth, and it provides soil porosity for the roots to actually explore and find nutrients to consume. Manure is I mean, it's a tale as old as time. And it also has to do with connect back with grazing, but we'll talk about that later. There's one study that showed that a single application of dairy manure to some soils retained improvements in carbon, phosphorus, and yield 16 years later after the application of manure. So it stays there for a very long time. Compost provides a lot of variation in nutrients. So these are kind of all together. You need to rotate your crops, or else it's just going to be very extractive. If you're growing the same plant over and over again, that soil is going to be drained. It's like it's just not going to, because if you grow the same plant, it needs the same amount of nutrients every time, and the same kind of nutrients every time. And cover cropping helps with not losing a lot of the air and denaturing of chemicals or compounds in the soil, and that also can introduce new nutrients into the soil, like fixing more nitrogen. Okay, here's another contended topic is tilling. Most of the research that I've found is that reduced tillage is preferred. Not like completely no-till, because you still have to aerate. If you have too much compaction, you still needs air to breathe, but reduced tillage is the best. And soil health, all of this is important. You need to take care of the soil because that's where the microorganisms live. So they're the ones who facilitate nutrient uptake. And again, this is kind of like the soil is kind of like the plant's gut microbiota. So there's things like plant growth promoting bacteria that can make metals more bioavailable, and then either they'll use them themselves or they'll die in the soil, and then the plant can use it later on, or different fungi can use it later on, where this is actually a fungi growing in a root of a legume. And the soil, or the plant, gives the fungi carbon from the sun through photosynthesis, and then the fungi, using its hyphae, can actually break down nutrients more and minerals more readily, and they share with each other. How nice. And earthworms are shown to increase yield 25% in one study. These things compete with other pathogens, so either other bacteria that exist off of declining the plant's health, and also fungi that they can basically outcompete the pathogens. So fertilizer use affects soil life, and they can actually, if it's rightly available, they're not going to partner up with that fungi, and so they're describing as slacking off, and this can actually reduce phenols and other phytochemicals. And then pesticide residue just also kills microbiota. Okay, so we're gonna talk about this variance a little further. So this is a raspberry, in case you didn't know what it looked like, and this this study, this is about fertilizer. So this study essentially, the phosphorus content is 12 parts per million. They applied 3 different levels of fertilizer, 0, 22, and 40. So the black one is the highest, sorry, 44, excuse me. And they found that phosphorus had a higher, the largest amount of fertilizer had the highest amount of phosphorus. So this is great. It uptook more phosphorus. However, if you'll notice, lower amounts in all other nutrients. So it did a great job getting phosphorus, but this is an effect called environmental dilution, which we're going to talk about more, but essentially stop the uptake of other nutrients. So this is how fertilizer can affect, in the soil, can affect micronutrient levels. This is a pretty in-depth study. So essentially they paired organic and conventional farms in 8 different places across the United States. And basically, when comparing organic to conventional, the soil organic matter was higher, sometimes threefold. And then this is a Haney test, essentially a marker of soil health. And some of those were 6 times more healthier soil than compared to the conventional ones. So this is looking at like specific ratios of organic to conventional content. So see, cabbage had like 100% more vitamin B1. This one had all crops had about 20% more phenolics and other phytochemicals when compared to the conventional ones. And possibly the most hilarious one, there was an infinite amount more of vitamin B6 in organic sorghum compared to conventional sorghum. So I'm not going to read all these. You can if you would like. But I'm just showing this to say that there's more data comparing organic to conventional. And going back to what I said earlier is organic doesn't always consider actual regenerative practices. Like it could just be like a term that's slapped on. Oh, that's a Marionberry, by the way. It's a cultivar blackberry. If the study's green, that means they also did a concurrent analysis of the soil health. And they found that when soil health increased, micronutrient density also increased, and vice versa. So they looked at the soil too, not just the micronutrients. So if you're not a fan of vegetables, this goes out to my meat eaters here, because animal products have variation in nutrient density too. It depends more on the diversity of grazing, and rather than plant chemicals, it's different fatty acids and such, and just different proteins. So the more diverse your pasture grazing is, the more nutritious your milk, meat, and cheese is going to be, or any animal product. And in addition to improved shelf life and the reducing of off flavor. So chickens and turkeys are raised at an extremely fast rate nowadays, and this affects the taste, quality of the meat, as well as the nutritional content. And then also morbidity and mortality can increase, or it decreases when the higher the diversity is on their grazing land. So it's a little more complicated than grass-fed, because there's other things growing there than grass. And then a local farmer, Troy Salzer, said in a conversation that I had with him that he's not a cow farmer, but he's a grass farmer. His job is to cultivate grass and plants that the cows can eat. Here's just a few more. You would say, oh, this is a win for the grain-fed because it has higher amounts of 4-HNE, but 4-HNE is actually really bad for you. But then also keep in mind that like some of them are still pretty similar. And I don't want to put an ultimatum of high nutrient content overall, because like this is a volcano plot. Essentially, there's a lot of very high ones, but most of them are right here. That's total phytochemical score, and CLA inhibits breast cancer. So all that is to say is that there's significant nutrient variation in nutrient density. And this variation has decreased over time significantly. And in turn, the consumption of nutrient-dense food has decreased significantly. So what the hell happened? So we aren't eating enough micronutrients. 3/4 of the adult population in affluent countries aren't going to reach the amount of vitamins and minerals that they need. And over 3 billion people are expected to suffer from malnourishment of micronutrients. And this is because this decrease can be attributed to a consistent decline in vitamins and proteins. And in turn, we know how important organic matter is and how important soil health is. This is the Corn Belt, and 1/3 of the topsoil from the Corn Belt has completely eroded. In addition, I touched on the dilution effect of environmental dilution, but also there's something called genetic dilution, where in higher yield varieties of, let's say, broccoli, when you select for higher yield, you're only selecting for carbohydrate formation, and you're kind of ignoring the other effects. So this causes more emphasis on yield rather than the content of the nutrients. So on top of that, processed foods, I touched on that earlier in the presentation. Not very micronutrient dense at all. So so micronutrients are decreasing. It makes our food taste blander, and this can actually affect our connection between flavor feedback associations, so knowing what the right food is to eat. And especially individuals who don't have access to healthier foods can pay the price for this. They're disproportionately affected because they live in food deserts where they don't have direct access to. They only have a Dollar Tree or a fast food chain to go and actually get food. So this is all extremely overwhelming, but remember that micronutrients are important, and that an increase in micronutrients can offset the effects of these non-communicable diseases. So we need to increase the level of micronutrients in our crops and in our diet. This means healing the soil. There's no silver bullet, though. This is also a societal structural issue. I can talk about that for a very long time. But some stuff that you can do yourself is grow your own food, know your food producers, support community food economy. They are the ones doing it right. Also go to farmers markets this summer and make your own food, cook your own food. So I just want to acknowledge Ava, my beautiful girlfriend, and the Sarah's Table crew as well. I want to thank Dr. Betsy Garcia, my grandma, my sisters, Mia and Chloe, and my nephews, Woods and Milo. This presentation was dedicated to them and future generations. These are my works cited, and I will now answer questions if you have any. Yes. Yeah, so that would be once I also in the Zoom, there's only 5 minutes left because I have the free version of Zoom. So if you get disconnected, I think you should be able to just reconnect. Also type if you have any questions. So morbidity I take as essentially like necrotic tissue, also kind of connected to non-communicable diseases, just like overall like nastiness. That's not very scientific, but just like increased quality of life too for the So Um, um, it's kind of the over selection for yield, but that isn't a necessarily bad thing. And in fact, it is like crucial that we do that in order to feed everyone on Earth. Um, and I read that farming with healthy soil can offset, and with like earthworms can earthworms increase yield. Also, farming with more healthy soil can offset that dilution that happens when you select for high yield because it introduces more micronutrients. Does that make sense? Okay.
I have one clarifying question and one question. So,
Please.
did you minerals fall into, well, I guess more like soluble acid, like iron, or micronutrients, barrel. Um, my question, my main question is, so when we were discussing micronutrients, you did mention biochemicals, things like terpenes and they were listed amongst like pre-vitamins, right? And I can see how pre-vitamins are pretty crucial for like human health, but for like things like terpene or chlorophyll, I'm not sure how they would like actually. Is there like any proposed mechanism or how they would be like actually helpful to humans health?
Yeah, so those are good questions. Thank you. So that's part of the reason that I don't think that they're legally not considered essential. So like tocopherols, like vitamin E is tocopherol, and again, like I don't really know much about like the chemistry of it, but like so some phytochemicals are literally vitamins. The other terpenes and carotenoids and X phytochemical um, would contribute to um, those things like flavor and shelf life and vibrance and other non-nutritional, I suppose, like directly nutritional, or they would be something that the microbiota would use, even if it's not directly used for digestion. That makes sense. That's a satisfying answer. And then in addition, that's a good question with the different minerals and metals and things like that. It's really like wishy-washy in everything that I read in terms of like what's considered a micronutrient when it comes to things like iron or copper or even boron. Um, um, so they're they're kind of their own thing, I would say. They're not a macronutrient or a micronutrient, I guess, now that I'm saying that, but they're their own thing, but they are affected significantly by the same things that micronutrients are in zinc. Yep.
You think this, likely,
I mean, like, I mentioned manure, and in addition with crop rotation, you can rotate herbivores as well. And I mean, this is a natural process. Like bison or cows, they poop on the ground and then stomp on it because they're walking all over. So I know that introducing human fertilizer into food systems, like there's a reason we don't do that. Because like literally just there's pathogens that directly affect humans, and it's more complicated than putting cow manure or something like that into the ground. But cow manure or other types of manure have more diverse things in them than a phosphorus pellet has. So it's like that would lead to, if you're just using phosphorus pellets, yeah. So yeah, and so what you propose, I agree with, because then that leads to environmental dilution. There's no balance. You're just going for like one thing, or nitrogen. I see what you're getting at. And actually, not even kidding you, my grandma just asked like literally the same question. So she said that chicken manure has a higher nutrient concentration than cow manure. So I'll take your word for it. I'm not sure in terms of like you're saying like which animal's manure we should use. I think even that you shouldn't just use one. There should be ideally. Oh, this is another thing I wanted to say. Like the last thing I want to do is discourage anybody from eating any vegetables at all, because like, oh, there's no micronutrients in there anyway. I'm just not gonna like any vegetable consumption is better than none. So just like eat like don't let that discourage you being like, oh, these are bad vegetables or something like that. So
But, so you may know how waste them. Are we? Polyphenols, right? Yeah, so they do spread your waste on fields. It has to go through the anaerobic sludge process. So basically, that's what anaerobic digesters spend like 56 days in there, and then their sludge settles out. It's like take this sludge, big truck. Crops, right? So you will eventually get those heavy metals and other stuff. But you can only add so much per acre. Per unit of content. Very dull. You do get your own back.
full circle. Yeah.
I was curious if, it seems like you emphasize microbiology of the soil, microbiology of the human body, so just some action.
Yes. Yeah. I have like some let's see if I have like any. Oh, now you can see all my, no, just kidding. Okay. Like in terms of like them actually being in each place like at the same time, or I mean like, well because if you have a more phytochemically rich soil, then there will be more micronutrients or microorganisms there, and then that means that there's going to be more micronutrients in the fruit, and then there are like basically all of the phytochemicals uh uh activate or allow our gut microbiome to be more diverse. And they encourage growth of bacteria that might not otherwise be encouraged.
Soil health. Or
Most definitely.
any other questions? Thank you all for showing up.
Yeah, thanks, everybody.
Yeah, so I remember. Like, 10 minutes back. Thank you.
Well, yeah, so I don't.
Oh, yeah. So like, I think they're probably over there. Well, less than one.
Yeah, but.